All right, thanks everyone for coming, especially right after lunch. I know I get tired right after lunch, so I'll try and make it pretty exciting for you, keep the energy up a little bit. My name's Eric Mattingly. I'm a service engineer in Microsoft IT, actually, so the IT group that supports Microsoft as a company. And today we're going to talk preparing to support enterprise applications on Windows Azure. And during the talk, feel free to ask questions. You can interrupt me, stop me, ask questions, and I can address them during the talk right there. So I want to set just a couple expectations. This is a 300 level, so I'm not going to go into the basics of Azure and how it works. I expect you to have some understanding of that. I might draw in a little bit. You can ask questions, feel free. But I'm not going to cover it in the slide deck. And we announced a lot of great stuff a couple weeks ago. A lot of great sessions on it this week about virtual machine, virtual network. I'm going to lightly touch that stuff, but this talk is not going to be directly about those technologies. And right at the beginning, we'll discuss why that is. So this is your cue if you want to bounce out. I won't be offended at all. So a couple questions, questions I hope everyone here has. Maybe this is why you're at the talk. We're going to look at what steps to build and deploy a supportable Azure app. Okay, so there's dev tracks about building the apps, but the supportable thing is the interesting part of it, right? And it's a little bit different than your typical on-premise application, what you would typically write. How are the troubleshooting different when you're in Azure? There's a lot of similarities. We'll talk about that, and there's some differences, so we'll discuss that part. And now that you're in this public cloud and you're running on Microsoft systems, you're using Microsoft services, how do you figure out if it's your code or maybe something's going on in the data center? How do you know when to call Azure support? Where's that line drawn? So it's an interesting problem. That's a new type of thing with Windows Azure and with the public cloud. So in the first section, we'll talk about the design of it. And we're actually going to go through very, very briefly the parts of leading up to production. And to give you a little bit of background about me, I work in support. So I support Azure applications. As part of Microsoft IT, we do a first and best initiative where we dog food all of the product group products and give them lots of feedback, which includes Azure. So I support a platform as a service, a PaaS Azure application that we've had in since about, I think it was August last year is when we put it in. So a lot of learnings. And I'll go over the best practices of that. And even though I'm in support, I'm still part of the whole life cycle. And I still have a voice when it comes to the design of the app, how it's developed, how it's tested. Because I want to make sure that that app is supportable when it hits when I need to actually sit there and support it, right? That I have the tools that I need, and it's not just thrown over the wall. So that's what my role is, and that's where this content comes from. So we'll talk a little bit about dev stuff, but it's going to be from the support side, and it's going to be what support personnel are interested. One thing I am curious, so how many people here are actually running something on Azure right now? Is anybody here running? A few people, okay. That's good. So this is why I'm not going to talk about a lot of stuff that we announced. And that is, everything we announced was release preview. There's a lot of great technologies in Azure. Most of it right now is still CTP or considered release preview. And that's definitely the first step when you're talking about a supportable Azure application, because the technologies like Traffic Manager, Data Sync, virtual machines, virtual network, VM role, Azure Connect, these are all beta. They're not production, and they're not supported with somebody that you can pick up and call. They're supported through the forums. You don't want to be using these technologies, having an incident, and suddenly you have nobody to call. All you can do is write a forum post and hope somebody replies in time. So this is why I'm not going to go drill into that, because we want to talk about things that are released in production right now. Your boss says, hey, let's put something on Azure today. What can you do with that? So leading into that, so the design. Really, right now, today, platform as a service is what we would say to go to for a supportable app, so you're not using these pre-beta technologies. And platform as a service is always that endpoint too. So even when the new stuff becomes general availability in production, you want to eventually go to platform as a service and kind of mix it until there. For the Azure technologies that are in place, a couple of them do very similar things. So SQL Azure, you can store data, you can query data. Azure Storage, you can do the same thing. Azure Storage is table storage, which is very similar to like a SQL, if you're just using SQL that way. There's trade-offs between the two, right? And from a support standpoint specifically, there are trade-offs when it comes to backups. There's SQL Azure. There's no point-in-time backups right now. You would have to do copy as. It's pretty easy to back up, so that's one good thing with Azure Storage. It's a little bit more difficult. You might have to write your own custom tools to bring it down. If it's something that people need to look at the back end and they need to maybe update things, it might be a little more difficult to update Azure Storage, a little more difficult to query Azure Storage. Maybe it's good for SQL Azure there. SQL Azure does have size limitations, and it doesn't have a performance SLA right now. So there's no guaranteed performance. Whereas Azure Storage can grow very, very large. You can put a ton of stuff in there, and it does have a performance SLA. So that's another thing from a support perspective. There's trade-offs from both. So that's something you want to analyze as part of the application you're looking at. Another one is, how do you talk back to an on-premise system? So if you're looking at a hybrid app, a lot of the apps that we do inside of Microsoft are hybrid apps. There's technologies, multiple ones that you can use to do that. The two of the production ones say you can have a public web service that's just exposed and have your Azure deployments talk down to that, or you can use the service bus relay functionality. Same type of thing. It's understanding the trade-offs between the two from a support perspective. Public web service, obviously it's public. Anybody can hit it. That's potentially an issue. Service bus relay, it does some interesting things, and we'll talk about that. We'll actually dig into that a little bit when we go into troubleshooting. So that's looking at the design perspective from a support. And developing, like I said, it's not really a dev talk, but some things that are particularly interesting for support. And big thing is the resilient connection points. So in Azure, there can be blips. And it can happen a little bit more than happens in an on-premise environment. So anytime you're connecting outside of your instances, you're connecting to Azure services, connecting to on-premises, connection points need to be resilient. And if they're not, you might see some kind of wonky things going on. A great example of this is the app I support does workflows. And when there's connection issues, the workflows get into kind of a bizarre state, very difficult to support from there. People will call in and say, what's going on with this? Why is this happening? And it's because of these connection points. They're not resilient. So Patterns and Practices actually has a application block you can use that will make your connections to SQL Azure, to cache, to storage resilient. So it's something you want to make sure if you're a developer, you use it, or if you're in support, you tell your developers to use it. And then, this is kind of basic Azure, but it's good to mention. There's a paradigm shift, right? Same thing. Your apps need to be multi-instance because you need more than one instance of any role to have the guaranteed SLA of 99.95. So you have to do multi-instance. It's stateless. They can come down at any time. If there's hardware failures, you might lose that instance. And that's the instance failure tolerance. So just another thing, just maybe making sure your developers understand that when you're migrating an app, there might be some changes that have to be made there, and with a V1 app as well. The instrumentation, something that, as a support person, you kind of live and die by. Is how well is the app instrumented? How much information is it emitting to you? And the good news is, in Windows Azure, all of the basic stuff, kind of the groundwork, the usual things that you're used to on-premise still applies. So there still are perf counters that you can collect. So if you're using custom perf counters, you can still use those. Eventing is exactly the same. So that's a good thing. If you're migrating an app, when it comes to your diagnostics, you shouldn't have to do too much. You shouldn't really have to do anything. And if you're developing new stuff, you don't need to do anything special as a dev. You're still just writing the usual things. You're writing events out to the event log, using .NET Trace if you use that, using perf counters if you want to use that. One thing to keep in mind is there is an IntelliTrace feature that developers can use in pre-production. It's not supported in production, however, so that they want to make sure they're not using that when it goes into production. Windows Azure Diagnostics. I'm not going to dig very deep into this. I hope you have kind of a general understanding of it. If you don't, feel free to ask a question. But it basically will collect all the information, this list of information from your role instances, and it'll move it to Azure storage. And that is because of this stateless, this failure tolerance. So if the role instance goes down, you usually will have something that tells you why it went down, maybe your app crashed, something like that. You need to get to that diagnostic data. So Windows Azure Diagnostics will actually move that over in a specified time interval that we'll look into and you can specify. Move it into Azure storage so you can get to it, which is a good thing. You can always have the data that you need, and you get a nice side effect that you actually have all the data in one place. If you have 100 on-premise servers, maybe you had to write your own code to collect the event logs from all of those and move it to a box or collect the IS logs, try to do all this multi-server stuff. Nice thing about Azure is it all goes into Windows Azure storage. It's all in one spot, and you can just go right there to look at it. Going into the talking about the resilient connection points, it's much more important now in the Windows Azure world that developers instrument around consuming these platform services. So issues can arise with connecting to SQL Azure. We'll talk about that a little bit. Connecting a cache service bus, etc. It's up to the developer, of course, to write that out somewhere, to an event log, to .NET Trace, somewhere you can consume. And they might not be doing this, now with typical apps. They just kind of take stuff for granted, right? So one thing that we learned early on is our developers, we had to influence them to really have very robust eventing, robust diagnostics around these connection points to your Azure services that you're using. When we talked about Azure Diagnostics, what it does, there's a bunch of different ways to configure it. And you can do it with PowerShell, you can do it on the fly, you can control the interval. The best practice that we really found is to use what's known as the Windows Azure Diagnostics configuration file. So I'll go into a demo right after this slide about that. Basically what that is it's an XML file that you deploy along with your app that defines what you want to collect and how often you want to collect it. And by doing it there, it'll be pushed out to all your instances, no matter if they get flattened or not. So there's no changes there. It's in a file, so it's not being done in code, so you can share it across multiple applications. It's a lot easier to test, and we'll talk about the testing, because you'll want to test to make sure the diagnostics is working as expected. So I'm going to bounce over to the demo box here. And we'll look at Visual Studio. Let me bring that up. And we're just going to look at a sample app, and specifically just the diagnostics, this file, and how it's configured. To give you an idea, I'll talk a little bit about some of the best practices with configuring the file. Here it comes. So I have an Azure project right here. If you're not a developer, that's okay. The one thing that is interesting with this is there's just a file in the root, and it's a diagnostics.wad CFG. Diagnostics is sometimes referred to as WAD. You'll see that in forums and places. Just stands for Windows Azure Diagnostics. So the Windows Azure Diagnostics config file. And here's how it looks. Just going to run through kind of the overview of it. You're defining in it how often you're transferring. So we're saying transfer infrastructure logs every 1 minute, transfer logs, which includes IIS, failed request tracing every 1 minute, transfer performance counters every 5 minutes. And we're listing out all the perf counters we want. So the basic perf counters, CPU, we like to do a little more than the basics. One tool that we love on-premise is the PAL tool, the Performance Analysis of Logs tool. And they can give you some templates. So for web roles, we typically are interested in requests per second, request execution time, request queued. A lot of those ones to give us some great insight of just what's going on with that app. So by defining it in this one file, we can share that with all the teams that are developing Azure apps. We can tune it right here. So going through the counters, at the very end is where you define the event logs. So here, I'm only collecting the application event log, and I'm saying collect everything in it. You can give it some type of filter. You can say only collect warning events or higher, stuff like that. If you have custom event logs, you can add that in the bottom here. So as I said before, it's just like an on-premise server. So if they're using custom event logs and not just logging everything to the application, that's fine. The Windows Azure Diagnostics will handle that without an issue. So any questions about this, about what this file is and how it's used? Like I said, there's kind of multiple ways to get at diagnostics in Windows Azure. Don't really have time to go through all of it in this session, but I want to go hit some of the best practices, and we found this is the best way to do this, the easiest way to do it. So also, as part of the developing, one thing that you can do is you can have startup tasks. And what a startup task is it's something that runs when this instance is created. And that's where the developers might need to do stuff like configure IIS with certain settings, configure the server, that VM, with certain settings. And by VM, I just mean an Azure role instance. It's a VM when you come right down to it, so I'll say VM during this talk. But you can also do support type stuff with it. And one example is you can install software that you want. So with Windows Azure, it's a VM. You can remote desktop into it. And you can also use tools that you use every day with an on-premise server. So if you want those tools readily available, a great example is we do group policies at Microsoft to push out specific tools to all the servers, WinDBG, for example. So it's there for you. You don't have to do it. Well, you can do that as well as part of your deployment. And it's a great value. You don't want to, I'll caution, you don't want to put everything through it this way. And I'll show you another way you can get at tools onto the server. But it's a good thing to have kind of in your back pocket, something that you can use. So we're going to jump back to this solution right here. And we're going to look at what that entails. So in this Azure solution, there is a configuration file and a service definition file that makes up the Azure project. And in the definition file, they're under this web role. So I have one web role. It's got 2 instances. And you see here I have a startup and then a task. So with this task, it's going to run this command file, and I have that as part of the project. And it's going to run elevated, meaning it's got administrator privileges. And then it's going to run in the background. So there's a couple different ways you can run it. You can run it in the background, or you can run it it's called simple, but it means it's basically in the path of that role starting up. So we like to do it in the background because that means if something happens, maybe there's an issue, it doesn't actually affect that instance starting up, and it won't affect your application. And you see in the project, all I have is just a folder, a startup folder. I have that command file, and I have software that I may want. So for this example, all I have is I'm going to use this Azure Storage Explorer, and I'm just going to make a directory, and then it will install it to that directory. So I'm not going to publish this. I'm going to cheat because that would take a long time. So I'm going to cheat and just remote desktop right in. So we're going to remote desktop into this site. One tip, actually, when you see this screen, so you can, of course, remote desktop into any of the VMs, and you can get this file from the management portal. On this screen, it's asking you, do you want to remember this connection? That's the VM's name. So if you hit yes, and the VM name changes because it breaks or something happens, you do a redeployment, this file basically stops working, and there's all these issues trying to get it to come back. So I would always recommend do not check the box, don't ask me again for this. That's one thing we learned very early on. So as it comes in here, that installation, all it did was copy it to the C drive. So I installed it under Tools, so now I have it as a C drive, Azure Storage Explorer. And I'm actually going to open this up because I want to talk about one other way that we can get tools onto this VM that's very popular within Microsoft. And that is we store tools onto a storage account. And we have one storage account that everybody can hit. So I have this already configured for my storage account. And I'll enlarge this. And if we go to blobs here, you see I just have a container called support tools. And under there I have debug diag and I have netmon. So this is a very popular way by not installing everything. So we don't want to do everything through a startup task, but if you're having an issue and you need to troubleshoot, instead of having to copy it up through the remote desktop, maybe it takes too long, maybe you have a lot of software, you can just pull it down using Storage Explorer. This tool that I'm using right here is available on CodePlex for free. So of course you can just click it, download it, pull it down, so you can pull, say, netmon installer down so you can use it. If I get out of this, there it is, of course. And you can install it. There's no issues with that. I won't continue. So there's two ways to get software up on it. So troubleshooting software if you are having issues. One way, the basic way, you got to work with your developers to put that in. And the other way, once you have that, you can use storage and have your tools in there and connect to it from any of the VMs and download it very easily that way. So now that we develop, I'm just going through kind of the basic cycle here. So we get to the test. And one of the things that we were really excited about is in our IT shop, we have a very nice production SAN, very nice production servers. Our test machines, not really up to the par. Is anybody else kind of in that same, their shop's that same situation, right? Your pre-production environments don't match your production environments. So when you're talking about testing, I'm not talking functional, but maybe load testing, response time, that type of thing. What do the numbers really mean? And the nice thing with Windows Azure is your pre-production environment might be sitting next to my production environment. It's all the same hardware. Right? So it's very powerful. It's very exciting from a support perspective because one of the great things about Azure is the scaling. You can scale your instances. If you have increased load, you can scale it out. If you have decreased load, you can scale it back in. But how do you know when to do that? It's great that you can, but where's that bottleneck? You need to learn that before you hit production, in my opinion. And you can use that using Visual Studio. So there's a web test and a load test feature in Visual Studio. You can load test those pre-production environments in Azure and learn what the bottleneck is. Is it CPU? Is it maybe a certain number of requests per second? Once you figure that out, that'll help with a couple things. It'll help with your instance size. So I'll talk about how do you choose the right instance sizes for your deployment. And as well as the scaling out. One nice thing that the Patterns and Practices team released is an auto-scaling application block. And what this does is it'll look into Windows Azure Storage at the diagnostics data, and it will scale out your instances based on the criteria that you give it. So in a perfect world, you load test your application, you find that CPU of this one web front end role is your bottleneck, where you can provide this XML file into your deployment, and it will say, all right, when that role CPU gets to 70%, add another instance. And when it goes below 70%, scale it down one. Very powerful. All automated, right? So hands-off does it for you. So a really great thing. Like I said, very exciting to have a similar pre-production as prod. Another part of the test is latency. All of our apps are hybrid apps that I support, and latency has an interesting effect on it. So we take for granted right now, usually if you have a typical line of business app, it has a web tier, it's talking to a database tier. Usually the web tier and the database tier are in the same data center. They're staying next to each other, maybe 1 millisecond of latency between the two, right? Now that you're in Azure, you might have your front ends. For us, example, we have them in North Central, but our SQL server's still sitting in Redmond. So suddenly there's 50 milliseconds of latency that has been introduced at that tier the application's never seen before. And there was one application in Microsoft IT that was transferring like megs, 5, 10 megs of data for every click that a user did on the front end. And when they had it on premise, it didn't matter. Nobody noticed it. It had no performance impact at all. When suddenly they moved the front ends into Azure, into the North Central database, the just performance was wrecked by it. So they had to do some re-architecting to tone down how much data they were transferring between those tiers. But it's an interesting problem. It's a problem that most apps might not experience right now in just an on-premise world. So there is a site, Azure Statistics, that'll give you an idea of the latency between data centers in Azure if you're going to put things in multiple spots in Azure. But just part of the test, it's a recommendation. Test, see what that latency is going to do to your application. See where your sweet spot is. This will help you decide where you want to deploy to. So which data center you want to deploy, whether it's, for us, of course, it's in the United States, or if it's in Europe, the West Europe, East Europe. Monitoring, we went into the diagnostics. We went into how you configure that. Well, you have to test that as well. So you need to test to make sure if you are getting the right data that you need. Is everything flowing, right? You need to test to make sure if there are issues with connection points that you get alerted on, what you need to get alerted on. So we call it failure mode analysis. It's another thing that we see not typically done with on-premise applications, and it becomes much more interesting in the Azure world. So we had to recommend to do that. And for the diagnostics, if you use a configuration file and it has maybe one error in it, it could break all of your diagnostics. So you need to test that. And there are steps to investigating problems with that. But you can do it all before you go into production so you don't see an issue there. You don't want to get into production and realize, hey, my perf counters aren't flowing, and then you have to do a redeployment to get that in. That wouldn't be a good discussion. And we talked about the bottleneck detection. We talked about load testing instance sizes. This is the up-to-date. I pulled it down a couple days ago, so this is the latest we have of the instance sizes. One thing that we learned was choosing extra large isn't always the right answer. And I say that because in the Azure world, it is dedicated cores. It's not shared. And when you have extra large, you have 8 cores, and that means the fabric needs to find a spot for 8 cores. And a great example when you go to the extreme is there was a team that didn't have an enterprise app. They had a kind of research type app that had 1,000 instances. And there were thousands of extra large instances. And it actually took them 2 days for it to create all the instances because it was trying to find spots for it. So that impacts. That's one thing. It's an interesting problem. With enterprise, it's not as big of a deal, but there is a latency for extra small. It's very easy to find, or small, it's very easy to find as opposed to extra large. And as well, with the instance sizes comes what I think is the most interesting, which is the allocated bandwidth. The allocated bandwidth, by the testing that you do very early on, you can figure out what's the lowest size I need, right? Because you want the smallest size, but the most number of them. It can make your deployments very resilient. So that's the recommendation that we have. Don't always go extra large. You should really have to kind of prove to yourself why you need to be extra large or large, and try to go for the lowest possible. And we just talked about it, choosing more instances at the smallest size, more upgrade domains. So how many people here are familiar with the upgrade domains and the fault domains? Any people familiar? People saw that talk? At the high level, what an upgrade domain is that's how Azure will do your deployments and how it will roll the deployments out. So you can get 5 upgrade domains by default. So if you do 5 instances, it'll roll it out 1 per instance. And you can go up to 20, and you can assign your instances to these upgrade domains. So for example, if you use all 20, and you have, say, 1 instance for each upgrade domain, it means it'll take the Azure Fabric a much longer time to do the deployments because it needs to do 1 at a time. 1, wait till it's finished, do the next one. Wait till it's finished, do the next one. So the more upgrade domains really means the longer the upgrade times, right? And we recommend you use as few as possible. You know, if you can use 2, that's great. It'll just do 2 at a time. So maybe if you have 20 instances, you'd put 10 in upgrade domain 0, 10 in upgrade domain 1. It just does 10, then does 10 again. Much quicker. Much, much quicker. The separate storage account for diagnostics. You can be using Azure Storage for just your application, like storing data in it. Your application has image files there. And of course, diagnostics goes to Azure Storage as well. One thing we found the best practice was if you separate the diagnostics out, then you can share that with everybody. You can share it with your devs. You can share it with the testers. Anybody who's interested in that, they can just look at that without having to have access to the production, right? Having access to your production data, you know, where they might accidentally do damage or maybe for just compliance reasons they can't have it. So best practice is use a separate storage account, put it somewhere else, and you can share it out with everybody. And everybody can be happy because I can say personally that's a huge thing in Microsoft IT, especially in my group of devs always complaining they don't have enough access to production, right? I'm not getting everything. You're not giving me everything I need, the visibility I need. This enables them to just have that visibility and get them off your back. And the last thing is enabling remote desktop. So you actually have to turn that on. It doesn't just come out of the box. So you have to tell it to do that. And you can tell that in the deployment or you can tell it in the portal. It's easier just to do it in that deployment, in that Visual Studio solution. So we just have them enable it there, have the password done there, and we know when it gets to production, it gets deployed, there'll be no issues. We can remote desktop into it just like any other machine. And now looking at the sustain. So now we have something in production, and we're supporting it. You know, what are we interested in? One thing is the guest OS updates. So the Azure Fabric will update your VM with all the security patches, and it can do this auto, meaning it'll look at those upgrade domains and flash 1 at a time, however many you do, or it can do controlled, which means you tell it when to do this. And you might do this because you want to test every patch. You might do this. That's really the only reason I can think of is if you want to test the security patches, make sure they don't break your application. So just understand going into it, you do have that control from a support perspective. Obviously, as a support guy, I want it auto because that's one of the great things about Azure is I don't have to care about patching anymore. It's a lot of fun on those Thursdays when I don't have to do that. So I push for auto. I'd say it's the same thing. You have to justify using controlled as opposed to auto. Next thing, upgrading the deployment itself. So you have it, you're releasing a new patch to it. There's 3 different ways you can do it. There's some other great sessions that go in depth into this. But just to be aware, you can do it in place, which means you have 0 downtime, and it will use the upgrade domains. You can do a VIP swap, which means you upload it to what's known as the staging slot, swap the VIP, and suddenly your staging's production, your production's now staging, which is nice. And then finally, do a redeploy, and that's when you actually delete your instances and do a full redeploy, and that does incur downtime. So there's reasons that you have to do one or the other, typically. Just being aware, you know, if you have a SQL server in the back end, say you're using SQL Azure, what might happen if you have multiple copies, multiple versions of your application running at a time. You know, if that's an issue, then in place might not be the best solution for you there. Maybe doing the VIP swap's the best solution. So understanding ahead of time, you know, how are you going to upgrade this app? How are you going to do the versioning of the app? We talked very little bit about the backup. And as a support, you know, backups obviously key for business continuity. So there's backups that happen, of course, inside the data center. Storage will duplicate itself for you. SQL Azure has 3 different copies for you. But we like to bring something back on premise in case something happens and we need to, restore that backup because maybe somebody updated, a table and they shouldn't have, that type of thing. A bad where query type thing, bad update statement. So just being aware that Azure Storage, there's some tools you can use, but it really requires a development effort to back that up and to back up what you need out of that. So being aware of that. And for SQL Azure, there's a couple different ways. You can just copy the database. So make a copy, and it will put it in wherever you want to put it. And then, of course, you're paying for that database, which is an issue, could be an issue. And then there's import-export, so you can export it to Azure Storage, and then you can pull it down to on-premise or then restore it to Azure from there. So being aware of what your options are there and what you might want to do. And the last thing is the data retention with regards to diagnostics. So, we talked about it's very cool that the diagnostics goes to Azure Storage. It's consolidated. Well, you're paying for that at the same time, right? And it's going to continue to grow and grow and grow as you're moving your event logs, your IIS logs, everything over. So you need to have a retention policy for that. How long are you going to keep it there? Are you going to move it down to on-premise, do something with it on-premise? You're going to always keep it in Azure Storage? Be aware of that because you're being billed for it. You're being billed for how much space you're using in storage. And one nice thing is if you use Operations Manager. So does anybody have Operations Manager in their environment right now? People using that to look at their app? Okay, one person at least. If you use the Azure Management Pack, which is the piece you import to monitor Azure, it will groom for you if you tell it to. So it'll actually clean out the event logs. It'll clean out .NET Trace and do this all for you so you don't have to worry about it. You can just say, just keep the last 12 hours in storage and then remove the rest of them. So now we kind of went through the whole development life cycle from a support perspective, things that are a little different, things you need to be aware of. So now that we're in production, let's talk a little bit about troubleshooting the Azure applications. And really, the first step to troubleshooting is even knowing you're having a problem. And the best practice we have right now for an enterprise application is to use System Center Operations Manager. So if you've seen the new preview site, I'm sure you've seen this, the new site, the new portal for Azure. It has some really interesting diagnostics in it. It can tell you CPU and stuff. It's very good for kind of basic applications. But when you have a robust a line of business app, you need to do a lot more monitoring of. Operations Manager is the way to go. And you have the Windows Azure Management Pack, which will allow you to view those performance counters, allow you to alert on events. So if an event is thrown in Azure, it'll move to storage, SCOM will read storage, and you'll get an alert just like if it was an on-premise server, so there's no difference. And same with SQL Azure. So SQL Azure, it's a different paradigm shift, right? It's not a server itself, really. It's just databases. And you need to monitor that as well. You're not monitoring for the same things because it's a shared service. But there's a management pack available that'll let you know how much data you're moving in and out. It'll alert you if your size is too big, which is really good to know because then you might want to upgrade your size. So you'll get that through the SQL Azure Management Pack. And then the availability, and we'll talk a little bit about that in the next couple slides, and that's just understanding is your application up or not, right? Doing the kind of outside-in monitoring of it. And put up trust but verify here. A lot of the stuff is abstracted away from you, right? You don't care about the hardware in Azure anymore, but you still need to verify that it's performing the way it should be, right? There's sometimes glitches in the data center. Servers have issues. They have hardware issues that manifest themselves in weird ways, right? Maybe the NIC is having an issue. It manifests itself in a weird way. You should trust Microsoft, of course, that we're doing everything we can, but you should also verify, and you can verify using perf counters by collecting, say, the network perf counters and then alerting on them through SCOM. So still highly recommend looking at those base counters. The outside in, this is the one thing that I'm going to talk about that is that's not released, although you can get onto the preview right now, and that is the global monitoring. So it's called GSM, and it allows you to understand the end user experience. And what it is SCOM will go and hit your website, and it'll tell you if you're available, where you're available from, the response time for it. And that has provided us visibility into almost every problem we have with our Azure application. And if we do currently a 17-step walkthrough of our application every 10 minutes. And by doing that alone, every time we've had an incident, whether it was us or whether it was something we needed to call Azure support for, it was caught through this and it was caught immediately. So I highly recommend doing an outside-in monitoring. One thing you can start to look at is using Operations Manager to do that as well. I'm going to do just a little demo on Operations Manager just to give you a little bit of visibility into some of the power and why we're really excited about using it. So I'm looking at what's known as the web console here. You can view SCOM data in multiple ways. So this is the website. And I have a sample app, which is a hybrid app. So we have stuff that's on-premise, stuff that's in Azure. And I have a view here that I've created. It's a dashboard, so we're going to look at a real-time dashboard. And the dashboard's going to tell us really all the stuff we need from a high level about how our app's performing. So on the top, we have our response time. So this is that outside in, telling us how long it's taking. And let me move this over so it's a little more visible. So real time, say 322. So saying how long it's taking response time. Then we have a request per second. So we have a role which has 2 instances. And we can see the load balancer is actually doing an all right job. Considering it's got a very, very low load. The load's being generated by the outside-in monitoring itself. But we can see that right here. We can see the CPU. We can see for SQL Azure, looking at the database session. So how kind of active is SQL Azure? We can see that here. And we can also see if we have an on-premise server, it's hitting the CPU of that on-premise server. It's a very powerful one-stop shop for looking at your hybrid application. And even though it's Azure, even though it's in the public cloud, you can still view it just like any on-premise server. And if you're already using SCOM, it's not a twist. It's not a change for people. The processes don't change. And SCOM, one thing I also highlight is, it'll alert you if you're having instances, so it won't, or if you're having issues. So it won't alert you if one instance goes down, because who really cares if you have multiple instances. But if a role suddenly becomes not available, it'll alert you for that and it'll tell you. And it does this all dynamically. So all you're doing is giving it some basic information, and it's figuring out on its own through the management APIs how many roles you have, how many instances, and it'll update that in real time. So there's no hand-holding. If you scale it out to 10 instances, that'll be reflected in SCOM. It'll pull the data, so there's no issues there. And we can look, I just also have a state dashboard. It's very basic as well. But you see we have one role, a Hello TechEd site, has 2 instances. SQL Azure is healthy right now. The application from the outside in is healthy. The on-premise server's having something wrong with it. But still, a nice view of a hybrid application. You can see everything in one view. Any questions about that? All right. So one of the, I would say, the classical things from a support perspective is viewing the events, right? Going to the event log. And it's something that's just subtly different now in Windows Azure. Big thing is, of course, you can remote desktop into your Azure instances, but only one person can do that at a time. So you can't have multiple people looking at it. So if you do want to look at the event log by just remoting in and looking, that's fine. There's no problems. You can still do that with Azure. But it's only one person at a time. Now that Diagnostics moves it into WAD, the storage, you can view it there. And there's lots of tools to be able to view it. But there are a couple drawbacks to this. So Windows Azure Storage, I'm not sure how familiar you are with it, but not all the columns are indexed. Only the row key, the partition key are indexed, and those together make that unique index for that row. So if you wanted to search for all your warning events or all your error events, it will take an extremely long time to do that. It's an issue, and it's just because they're not indexed in Azure storage. So that's a drawback. And it can be a little bit hard to read because you're just looking at a kind of a table here. It's all schlepped in one thing. It's not as easy as on the eyes as the event log itself. So what we've seen as the best practice and what we've ended up doing is we worked with the development team to move it from Windows Azure storage on-premise to a SQL server. And then that allowed us to, of course, query it a lot easier. It allowed us to view it a lot easier. It took a little bit of a development effort. Wasn't a lot. And it's very reusable, so we can reuse it without it on its application agnostic, right? So we found that was the best practice. It gives people a one-stop shop for looking at the event log itself. And since everything's consolidated in storage, you can get it there without an issue. Okay, talking about troubleshooting, so I alluded to this, I talked a little bit about it, but it's the same as an on-premise server, right? There's no changes. So if you have tools that you use when you're troubleshooting, the sysinternal suite, everybody loves that. If you go into debugging, use debug diag, WinDBG. That doesn't change. You can still use that in Azure. There's no changes to that. And we looked at different ways to get those tools onto the VMs itself, but you can still use it. You can still install whatever you want. Netmon, classic for support people to see what's going on with the traffic. Talking about the network, though, there's some interesting changes that happen with Azure applications. So the one I support in particular was an internal application, still is an internal application. But the problem is, if it's an intranet application, but it's on Azure, is it really intranet? And the answer is no. Because if it's on Azure, it's on the public internet at that point. Somebody can hit it from a library. Just because it's an internal-only app doesn't mean that somebody can hit it and try to get into it. So it raises just some interesting changes for troubleshooting, of course, if you're used to only intranet-only applications, because suddenly you're going off of the corporate network. So if our users are hitting it, our users are internal users hitting this internal app on Azure. In reality, they're leaving our corporate network onto the public internet, coming back in because we're Microsoft, but going into the Azure data centers at that point, right? And it's a different thing. So our support teams, we had to troubleshoot differently because we had to identify what are those network paths. You still use Netmon, Traceroute, Netstat, the typical tools, but understanding where your network paths are and what you can control when it's leaving your network is important. And I have one good story about this. It was an issue that we had actually, I guess it was 3 weeks ago now, and we're using Service Bus. And with Service Bus, we use as a relay, so our on-premise servers can talk to our Azure servers. And with Service Bus, it uses ACS to just verify to produce the endpoint. And when it goes to talk to ACS, that goes out onto the internet. And the issue we're having is our endpoint suddenly disappeared. So our outside-in monitoring told us, hey, your site's not working. It's because our Azure app couldn't talk down to an on-premise server, and it was because the Service Bus endpoints weren't there. And what we found was when our on-premise server was trying to publish those endpoints, it was trying to talk to ACS, Azure ACS, and the proxy was not letting it. Our proxy was refusing the connection. So we had great eventing, so we found that very quickly. But it was an interesting problem, right? So our own proxy was preventing our application from working, right? Just a great highlighting example of understanding the network paths, understanding what's going on with your app and where you need to be troubleshooting. Now, SQL Azure, if you're using SQL Azure, we do. From a support perspective, it's different. So some of the tools that you know and love for an on-premise SQL server, SQL Profiler, right now doesn't exist with SQL Azure, so you can't profile. If you're having deadlocks, hopefully you're getting events saying that your transaction deadlocked, but actually getting that deadlock graph you can't get right now. You can by calling Azure support, and they'll provide that deadlock graph for you because they have the visibility into it. But as the end user, currently right now, you do not have that visibility. So be aware about that. DMVs, very popular for troubleshooting performance issues. It's limited right now. Some of them don't apply because you're not on a server anymore. You have a database, and it's a shared database. And some of them just haven't been implemented yet, so being aware of what's there. And the management portal itself does give you some good visibility. You know, it's not all lost right now from a performance standpoint and from understanding how the app's doing. You can get a query plan. You can see, you know, if you need to be doing index tuning. You can see if it's optimized. You do get access to that sort of information, but just don't expect to get everything that you get with an on-premise server. And this is really the big thing with using SQL Azure, and the big thing that kind of the heartache that we have with troubleshooting problems and having our application work, and that's SQL Azure throttling. So is anybody familiar with throttling and what's involved with that? All right, so this is, it goes back to this paradigm of what SQL Azure is and what it isn't. And what it isn't is a server, and what it is a database that you have on a shared system. And because it's a shared system, other people can affect you, potentially, and you can affect other people. So how SQL Azure works around this is it'll throttle. It'll actually, you'll do a query to SQL, and it'll come back and it'll say, nah, why don't you retry in a little bit? And it'll give you an error code and tell you why it's doing this to you. And this goes back to you need very robust instrumenting to get that error code and decipher that error code. But it's the reality, and it's not a bad thing, because it might say just retry in a second, right? And you need to have the retry logic built in. You need to have the eventing built in just to let you know it's doing it. But you need to be aware of it. And there's two different types. There's a soft and a hard. So soft means you're doing too much. You're using too much CPU. We're going to throttle you. We're going to cool you off a little bit. And then the hard is the server in Azure that your database is running on is just having serious problems. And it's not you, but we're going to throttle you anyway. And this is the interesting one, because this is one that we experienced. We've only experienced it once, but this was something that we called Azure support for. So we told them, you know, hey, we're seeing throttling because we had the eventing, and we told them what the error code was, and they were able to help us out to unblock us with that. So, you know, having the eventing, having an understanding of the paradigm shift when it comes to SQL Azure is key with troubleshooting, because how this manifests to us is we see response times go up. You know, we use SQL Azure as a transactional database. Our outside in, once again, will come, SCOM will alert us and say, hey, response times went up 10 seconds all of a sudden, and it's sustained there for a while. And if we look, then we see there's also events saying we're being throttled. And then we can decide, is it our own doing? Maybe it's our own doing. We have too much load. Maybe we have unoptimized queries, that type of thing. Or is it something we need to call Azure support for? And there's Azure-specific tools. So you can use the tools you know and love now. But there are a couple interesting specific Azure tools. So I'm going to highlight two of them. One thing is isolating nodes, which is a very cool thing, that kind of a feature that you can do. And another is this VM Assistant tool. And once again, VM just refers to the fact that in the end, your Azure instance is a VM. It doesn't refer to virtual machines or the VM role. So we're going to look at this, these two specific tools. Let me come over here. So I'm going to remote desktop again into this, into a different machine. Yes. So the first one is the isolating instances. So one thing that can happen is you might have one specific instance that just looking wonky. Something's going on with it. You just need to troubleshoot it, right? Well, the problem is you don't have control over the Azure load balancer. You know, all your instances are behind a load balancer. It's going to send traffic to it. The one thing you can do is you can turn off that instance. You can stop it. But then how do you troubleshoot it, right? You can't actually be on the server and troubleshooting it. So there's a trick, and this trick is you can use PowerShell to set this specific server, this instance, to a state of busy. And this will prevent the load balancer. The load balancer will see that, won't send traffic to it. But you can still be on the server. You can still hit it locally. you can then troubleshoot it locally and see what's going on. So this is a pretty basic one, but as easy as going into PowerShell. I'm going to run it as an admin. And then you have to add the snap-in, so it's Microsoft.Windows Azure service runtime. And then once you add it, there's a commandlet that's set role instance status. So I'll just say set role instance status busy. And it's going to come back in and say, all right, I'm going to set you busy, and it's going to stay busy as long as this window is open. So I'm going to bounce over to the portal right now. And this will take a little bit of time to get to reflect in the portal. So I'll show you right now. I was on right here the 0 instance, so the first instance. So right now it's considered ready. And we're going to go look at this other tool, this VM Assistant tool. And when we come back, hopefully, it'll be at that point, it'll turn off. And you'll see how it's reflected in the portal. So as I'm going to just minimize this window. So as that gets updated in the portal, we're going to look at this other tool. So this is a tool, VM Assistant. It's on CodePlex, so it's free. And it was designed as a one-stop shop for understanding what's on your instance, looking at some of the logs on your instance, and for troubleshooting things that are Azure specific. So let me open this up. So when you open it up, it has a bunch of tabs on the top. And we'll just walk through a couple of them and look at them. So the VM config. This has the top view is interesting. So it's the VM configuration file. So you configure it when you deployed it, but then that gets translated into the fabric controller's configuration, which is a different viewing. But you can view that here, and you can look and have an understanding of how is this configured. And maybe if your configuration was off and you're looking through here, you'll see it a little differently here. So if we drill down into this, you can see I have my Web 0, so that node right there gives you some data about what it is. It's a software type, it's a package. It's IAS because it's a web role. So it'll give you some data about what it's running. The interesting stuff, the diagnostics, of course, interesting. It's got remote desktop enabled. And this is good. So this is some of the stuff we like to see. And this gives you an idea of the IP addresses. So what are the IP addresses of the specific instances? So if you're troubleshooting, talking between your instances or talking to another role, you can quickly get your IP addresses from here. And it goes and says we have remote desktop enabled, so you can see that that's reflected in this configuration file. And the forward are the same for this other instance. So Web 1, because there's Web 0 and Web 1, and we can see the IP address of that as well. So we can be on one instance, have this open, but really get data from all of our instances, which is good. So you don't have to go into each one and try to figure out what they are. And at the bottom left, provides you with the endpoints, tells you, right now, of course, we only have the web, which is port 80, and we have our remote forwarder stuff for the remote desktop. But we can click here. This is the IP address, and there's my application, right? So if I was coming through the public VIP, I would hit that app. But now, by doing it here, I'm hitting it locally, right? So I can troubleshoot it locally. As you can see, as I turned it busy. I can still get to it here. So the config's interesting. The VM health shows you some data about the actual VM itself. And it'll tell you the listing of, did the fabric turn this busy at one point? What points was it not ready? When it was starting up, there's a life cycle to an instance starting up, and you can understand how long things are taking here. So this is just reading those logs again. So this is very valuable if you're troubleshooting, you have an instance that just didn't start up right. You can come in here and look at some of the date times for that. Because it's not, you can look in the portal and it'll tell you what the status is, but that's changes, right? That's not a history you can go to. This is where you can get that history of the status changes. And the last one that I think is the interesting one is just the VM info. And that's kind of the high-level aggregate of everything. I'm running 1.6 SDK, so it's actually the older SDK right now. It tells you how long I've been up, 14 days. W3WP has only been up for 1 minute, though, so that's interesting. Give you some ideas around the IP addresses. A little easier to view it, right? It gives you the IP addresses for the external as well, for the VIP itself. So one-stop shop. One thing I like, I always get a kick out of this as a support person. I try my hardest to prevent this from happening, where that is when debug builds are deployed into production. So they give us a debug build and deploy it. That happens more than, sadly, I'd like. I've actually seen developers do it on purpose because they told me then the page would never time out, which I had to educate them on that before. So one thing, you can just take a look. You know, sometimes people like to use WinDBG or tools like that to see if it's a debug build, because you can't go on PDBs alone because you can have those with a release build. But this type of stuff that you can view here and just get some ideas around the deployment itself from a support perspective. So that's very valuable. So any questions on this tool? How this is helpful? So this is Azure-specific stuff. Yeah, this is the stuff that you wouldn't be used to from an on-premise server, but it's the data that you need, and it's one single place to go and look at it. So this PowerShell is still running, so we're going to cross our fingers here. Let me drop this down. Boom. Didn't take that long. So you can see here it's reflected now in our portal. So it's saying the role is offline. The instance is offline, excuse me. The role is set to transitioning. It'll just stay like that. So now, role's offline, that's great. I can go troubleshoot. It's still up, but I can still hit the site on it. The customers aren't being impacted because we're not sending traffic to the customers. So one of the handiest things when it comes to supporting apps on Azure. So I'm actually going to kill this window, and then at the very end, we'll glance again, and that should not be there anymore then. So come over to the slide deck. And now, finally, let's talk a little bit the app versus platform. So you're in a public cloud. You're running on Microsoft stuff. At what point is it your app that's causing problems, or what point is it maybe the platform causing problems? So the platform's a little bit of a black box, right? But there's some clues. There's clues to let you know kind of what's going on and enable you to dig a little deeper and talk to Azure support if you have to. So one of the best tools there actually is there is a service dashboard. So people who have stuff running on Azure right now, are you familiar with the service dashboard and what that provides? So what that is it actually will have an RSS feed for all Azure services in all Azure data centers that you can subscribe to, and it'll tell you the health of them. So if an issue arises in one of the data centers with SQL Azure or with Azure Cache, something like that, you can get it from here, right? And it'll update you in real time. The thing, though, that's kind of interesting is that might not apply to you, right? So if you're using SQL Azure in the West Europe data center and you subscribe to the feed and it says there are issues, that doesn't necessarily mean you're having issues, right? And at the same time, if you are having issues, it might not be reflected in the portal, right? Because maybe it's something that's tied only specifically to the hardware that yours running on. There's a hardware failure, and it's just not picking it up, that type of thing. So it's a data point. That's what we like to call it. There were talks in IT that they wanted all of these RSS feeds pointed to our line 1. So, and I had to kind of stomp on that pretty early on and say, well, wait a minute, it's not always going to apply. People might start freaking out if they see there's an issue in this one data center, but our app is fine, right? So just use it as a data point, but it's still a very valuable data point. And talking, specifically about the app versus platform, really the biggest thing I can say is knowing your app to begin with, right? If you are running an app for months in Azure and haven't been doing deployments, and all of a sudden something's just acting wonky, short of maybe like a memory leak that's a memory leak that lasted months, which would be crazy, it's probably something platform related, right? So it sounds kind of basic, but truly understanding your app, having that gut check for your app is very useful when it comes to this stuff. If you just did a deployment and all of a sudden you're having issues, it's very likely it had something to do with the deployment. If you've been running for weeks or for months, no issues, very likely it's probably platform related. The role instances never ready, that's kind of the classic one. So you saw in the portal, the role instances have statuses, and they'll go through different statuses in their life cycle of starting up. But if your instances never get to that ready status, that's an indicator that there's an issue, something we want to call Azure support for. Also, communication between role instances. So suddenly you have, if you have web services in Azure and also a web tier, the web tier is talking to web services, but they can't talk to each other. You've seen Netmon saying they can't talk to each other. It's obviously something that's platform type related networking that's worth calling Azure support for. The SQL Azure clues. And we talked about this, but kind of drill it home is the different types of throttling. When you get this error code, so if you get retried, we call it getting retried, you'll see an exception that looks just like this. And it just says the service is busy, retry the request, kind of this blanket thing. But it gives you this code, and that code's the key, because that code will let you tell you what's going on. Is it me? Is it the platform itself? So by capturing that, viewing that code, that'll give you an indicator, do I need to call Azure support or not? And I linked earlier in the slide deck, there is a site out there on TechNet which gives you kind of the readout of what the codes mean. So it's very nice to have. One trick that we actually do with that is you can put that all in like a enum and then have that built into your app. So when you write out the exceptions, it just writes out a friendly message as opposed to this, this code that somebody's got to go look up. Azure Cache, so we haven't talked about this, but most apps, if you're using session state, you would put your session state into Azure Cache. Or if you're just doing any type of caching, you'd put it into Azure Cache. And I'm talking about the cache as a service. And this is, I would say, kind of the classic exception that we see. So we only use cache for session state, but we were seeing exceptions that look like this at one point. So they're saying it's temporary failure, retry later. Well, we can't even handle that because it's session state, so it was bubbling up too high. And it's a service, it's not us. So this was a very, very clear indicator that something was going on with the platform we needed to call. And we did, and we got it fixed up, patched up very, very quickly. So and the endpoints for the service bus. I spoke about the one example where endpoints weren't being published. The nice thing about when they are published is there's an Atom feed. So you can actually hit this URL, that's the servicebus.windows.net, whatever you call it, .servicebus.windows.net, and it'll tell you what your endpoints are. So we actually hit that with our outside-in monitoring, and we monitor it that way. And if the endpoints aren't there, that is an issue for us. It says that they're not being published. So that's one way we use, and we troubleshooted. That was on us. But maybe it wasn't on us. In future times, maybe it's not the proxy. It's something's going on. You need to call Azure support, and you'll see it from your front ends because you'll get exceptions that just say endpoint not found, right? So hopefully, if you get all the instrumentation you want in, when something like this happens, you're getting alerts from all different types of locations telling you what's going on. Now, contacting Azure support. Big thing to note right now is it's free, right? Azure support is completely free. It's that for the foreseeable future. So if you have issues, even if you're suspecting or not, call them. It's not a problem, right? If it's a prize 0, it's bringing you down, they will call you immediately and you'll engage right there. If it's something that's lesser, you'll work over email with them. But feel free to contact them. It's free. It's not like PSS where you'd have to the Premier service or anything like that. And you go to it through the support portal on Windows Azure. So there's the windowsazure.com, and there's a support section. So you just create a ticket in there. And one thing we found, it's kind of, I guess, a little silly, but the best practices is have all your information ready. It's very valuable to have a listing on a Word doc somewhere that says your subscription ID, your deployment ID, your technologies, and just a brief paragraph about your app. And that way, if you're having an issue, instead of having to fumble around and get the data and all that, you just copy and paste it. It's funny how much time this saves, but it's very worthwhile when it comes to Azure, because that's the first thing they'll say. They'll say, what are you using? And they'll say, what's your subscription ID, all of that. Just have it ready. Of course, if you think you know what it is, tell them, and give them the data to prove it. Don't just say something. Don't just say, I think, Service Bus is having an issue. Say, my endpoints aren't being published. I'm getting these events. Send it all in one swap, and they'll route you correctly to the person very, very quickly. Provide a shared email. If they're coming back, they don't want to talk to just one person. If you're on a team, we have a global team. So we need to make sure that if they're coming back in a different time period, it's going to the whole team and not just the first person. So I'm going to reiterate it again. It's free, so feel free to call. Even if you don't think it's an issue, if you have just a tiny hint that it's an Azure issue, call it. They'll work with you. Because even if it's your own issue, they'll still work with you to understand what happened and to help you troubleshoot it and to help you prevent it from happening in the future. So that's the end. There's a couple of related contents. There's one, the monitoring and managing in Windows Azure. Give you a little more details on the portal, the new portal, and some of the great stuff there. The one on hybrids will rule. This is a great talk. It's actually happening at this time. He's competing against me, and he highlights the app I work on. So if you want to learn more about hybrid applications and how we do it in Microsoft IT and some of our lessons with that, definitely highly suggest looking at this talk later on the portal for TechEd Europe. And then if you're interested in Operations Manager, there's sessions of that, of course, as well. So I will say thank you for coming. Please provide feedback. Let me know, how I did. Let me know about the content. If you think the content was good, if you think the content needs some tuning, please provide that feedback. We know Azure is a new type of thing, new technology. People start to ramp up on it. Supporting it's going to become more and more important as more and more people need to do it. So, if anyone has any questions, feel free to ask now or come up to me afterwards. And if not, enjoy the rest of the conference, and thank you for coming.